Okay. So hopefully in the video that you watched on Friday, it helped you to start reviewing fractions. Okay? And fractions is typically one of those things that we don't love. It's one of those things that make us uncomfortable and like, oh, do I have to do fractions? Yes, we have to do fractions. Okay? Now, in this particular problem right here, we have fractions and we have to follow the order of operations. Okay? So the first part of order of operations is, I'm actually going to call that grouping symbols. Parentheses is part of that. So I did hear parentheses, and you are correct, but it's broader than that. You know, you can have brackets, you can have a fraction bar, you can have different things like that. So it's grouping symbols. The second thing that we do with order of operations is we do exponents. Okay? We do exponents. We will do just a hint with square roots. And square roots fall under the same level as exponents. So you can almost say exponents and square roots. Now, for those of you that remember PEMDAS, and please excuse my dear Aunt Sally, this step is the step that messes up students. Okay? You do multiplication and division at the same time. Okay? You start on the left and you do it across to the right. Now, Facebook loves to put up little memes that are like 90% of people get this wrong and all that kind of stuff. And the reason that 90% of the people get that wrong is not because PEMDAS was taught wrong in high school, it's that we remember it incorrectly. So when PEMDAS was taught in high school, very likely your instructor said, okay, P is for grouping symbols, E is for exponents, M and D are for multiplication and division. And you've got to do multiplication and division at the same time. But 5 years later, when we're an adult or we're sitting down and we're helping our teenager, all we remember is PEMDAS. So PEMDAS has done its job because we remember it, but we see the M and the D, so we do all of multiplication before we do division. And you can't do that. You've got to do multiplication and division at the same time. So you can still use PEMDAS, and please excuse my dear Aunt Sally, to help you remember the order of operations. But you have to remember that multiplication and division occurs at the same time, as well as addition and subtraction. Okay? And you're going to do both of those from left to right. Okay? That's your order of operations. Now, here is my first fraction right here. I've got negative 2 and 1/3. Negative 2 and 1/3. That is what we call a mixed number. A mixed number. Now, in algebra, you're going to need that to be an improper fraction. So anytime we're dealing with rationals, and rationals are just fancy fractions, okay, it's much, much better to have that as an improper fraction. So the first thing that we're going to do right here is we are going to turn this improper fraction, or this mixed number, into an improper fraction. So we already know it's negative. Okay, so I'm going to ignore that negative sign. I've brought that negative sign down, and once I bring that negative sign down, I'm just going to ignore it. Okay, now I've got 3 times 2. What's 3 times 2? 6. And then I'm going to add 1. 3 times 2 is 6, plus 1 is 7. Okay, that's how I change a mixed number to an improper fraction. And that's what I did first. Now I've got 4 over 1. I'm just changing that 4 and putting a denominator with it. 4 over 1 and 4 is the same exact thing. And I am multiplying that times negative 2 over 3. Do you see how I moved that negative sign to my numerator? It's a pretty good habit to get into because you don't lose your negatives. A lot of students lose their negatives because they don't know where to put them. So one of the things that I do is I put everything in the numerator. I just bump everything right up there. Okay? Now, I am subtracting a negative. What happens there? It's plus. Okay, and you can go ahead and deal with that right now. Okay, 5 becomes 5 over 1. Then I've got negative 1/3. So I'm going to put that negative in the top. There we go. So I have just rewritten this problem. That's all I've done is rewritten it. Okay, I changed my mixed number to an improper fraction. Then I rewrote 4 as 4 over 1, and I rewrote 5 as 5 over 1 after I did the negative. Okay, now this is a negative value. I have addition, I have multiplication, I have addition, and I have multiplication. What do I have to do first? Good. Both sets of multiplication. So I'm going to leave my negative 7 over 3. I'm going to do 4 times negative 2. So 4 times negative 2 is negative 8. 1 times 3 is 3. Okay? 5 times negative 1 is negative 5. 1 times 3 is 3. Now, I have a hopefully somewhat nice addition. When I am adding fractions, I have to have common denominator. And what do I do with the numerators? Add them up. You're absolutely right. So negative 7 plus negative 8 plus negative 5. Okay, negative 7 plus negative 8 plus negative 5. Does that give me negative 20? Yes. I hope it does. Yes, I heard somebody say yes. Thank you. Negative 20. Okay, now, that is an improper fraction. Okay? Negative 20 over 3 is improper, just like negative 7 over 3. This is okay. I want you to leave it improper. Leave it improper. Okay? Okay. Now let's put that order of operations to good use. We ready? Okay. Whoops. There we go. Now, I've got negative 24 divided by 4 plus 8 times negative 5 minus negative 5 times 3. Okay? My first order of operation is grouping symbols. So what you want to ask yourself, is there anything inside these parentheses? I'm not talking about the fact that they have parentheses around the number. I'm talking about inside of them. Is there anything inside those parentheses that can be simplified? The negatives. You could, yeah. You change the negative to plus? Yes, we absolutely could do that. That is a good habit to get into. So this right here becomes plus. Yes, I agree with that. Okay? But is there anything with the negative 5 that can be added to the negative 5? No. So grouping symbol is taken care of. Okay? Do I have any exponents? No. Exponents are taken care of. Now I'm going to multiply and divide from left to right. So this negative 24 divided by 4, that has to happen first. Okay? So negative 24 divided by 4. Good. Negative 6. Now, I can't do anything with that plus, so I'm just going to bring it down. Now I have to do 8 times negative 5. What's 8 times negative 5?
Negative 40.
Excellent. Okay. Then I've got a plus. 5 times 3.
Negative 15. Oh, positive.
It's positive 15, but good. Good. Okay. Now I want you to add those 3 numbers together for me. And remember, in this class, you can't use a calculator. You can't use a calculator. Okay? And that's not my decision. It comes from way higher than me. Way higher than me. What'd you get? Did you get negative 31? Good. Let's talk about that for just a second. Okay. Negative 6 and negative 40. They are both negative. A negative number plus a negative number gives me a negative number. Always. A negative plus a negative gives me a negative. Now, a negative times a negative gives me what? Positive. That's where students get confused. Because a lot of students will say, Alicia, I swear that's positive. It's not, But if it was multiplied together, it would be positive. So a negative plus a negative is a negative. Okay? Now, when they have the same side and we're adding, we add their absolute values. So I get negative 46. Okay? Now I am adding to that positive 15. So I have negative 46 plus positive 15. They have different signs. I've got one negative and one positive. Which one of those numbers has the higher absolute value? That means it's further from 0. 46. So my answer is going to be negative. And because I have different signs, what am I going to do with those absolute values?
Subtract.
Excellent. Okay? And that was what a lot of the video on Friday was about. Addition, subtraction, all that good stuff. Okay, so go back and if you're not quite sure what I'm talking about, don't hesitate to go back and review that. Okay, here we go. Now, here we have two grouping symbols. I have negative 7.3 minus 2. Inside of brackets, I've got negative 4.6 times 6 minus 7. We are going to go to the innermost grouping symbol. Okay? So here is my innermost grouping symbol right there. 6 minus 7. Okay? So that's what I'm going to do first. I'm just going to bring everything else down. Negative 7.3 minus 2. Negative 4.6. And what's 6 minus 7? Excellent. Okay? Now I'm going to deal with this grouping symbol. So I have negative 7.3 minus 2. And inside brackets, I've got negative 4.6 times negative 1. Whoops.
4.6.
It is positive 4.6. Thank you. So I have negative 7.3, negative 2 times positive 4.6. Now, I want you to look right here, right there. Okay? I don't have a double negative. I don't have minus negative 2. That's not what I have. I have negative 7.3 minus 2. Some students, for them to get this clear in their brain, they have to write it down as plus and negative, and that is 100% okay. So they may need to write it as plus negative 2. You do not have to do it that way. Some people choose to do it that way, and some people don't. What you have to realize is that this minus sign belongs to that 2, and it's still subtraction, but the subtraction belongs to the 2. Okay? And so we are multiplying a negative 2 times this. And when we do the distributive property, that'll be super important as well. Okay? So I've got negative 2 times 4.6. And our brains may need a reminder. Here's 4.6 times negative 2. I'm just going to go ahead and put this negative down here so that I don't have to worry about it up here. Because what I'm doing on the right-hand side is computation. Okay? I'm doing computation over there. I've written my negative down where my answer is going to go. 2 times 6 is 12. 4 times 2 is 8. And 8 plus 1 is 9. Okay? Now, 92 is not the correct answer. It is 9.2. The reason it is 9.2 is because I've got that decimal. I have one decimal space right here. So in my answer, I also have to have one decimal space. Okay? So then I have negative 9.2. Now, I have negative 7.3 minus 9.2. You can think of that as negative 7.3 plus negative 9.2. Okay? My answer is going to be negative. So I'm going to go ahead and write that negative right there. We're adding the absolute values. So I'm going to have 7.3 plus 9.2. You got to line up those decimals when you're adding decimals. You won't do a ton with decimals in this class, but you'll do a little bit. Okay? We doing okay? Okay. Here we go. What I want you to do right now, I'm going to give you 60 seconds to do it. I want you to do just this part right here. Just what's inside those parentheses right there. That's what I want you to do. Okay? Okay. Hopefully, you realized you've got to do 3 times -7 first. That's going to give you -21. Okay? You can think of this as plus -2, and that gives you -18. I add those two together and got -39. Okay? Now I'm going to give you 60 seconds to do the next one. So you are doing just this right here. You did 5 times -7 first and got -35. Then you did 3 times 9 and got 27. Added those two together and get -8. The reason your answer is -8 is because we have one positive number. We are adding it to a negative number. Or technically, we have a negative number that we're adding a positive number to. Okay? The negative number has the greatest absolute value. That means it's the farthest from 0. I take that sign, and then I subtract those two values. Think about a bank. Think about a bank, okay? If I go in the hole and overdraft my account $200, is that the same thing as having -$200? Can you think about it the same way? -$200? And I put $100 in the bank. How much in the bank do I have now? Am I still in the hole?
0.
Yes, I have less than 0. -100, okay? So think about that when you're adding positive and negative numbers. Okay, now, what is happening right here? What operation is happening right there? Multiplication. Anytime you got things bumped up together and no sign, it's multiplication. Okay? Now, let's remind ourselves, negative times a negative, what am I going to get?
Positive.
That's the one we always remember. The negative times a negative is a positive. So our answer here is going to be positive. I'm going to multiply 39 times 8. That's my computation that I'm doing off to the side because I'm not going to have a calculator. 8 times 9 is 72. 8 times 3 is 24. plus 7 is 31. So my answer to this is 312. Do I have to have that plus there? No. I can, but I don't have to. Okay? Okay. Now we're moving into something that we usually remember and we like a little bit better. Okay? Can I move to the next screen? We good? Okay. Don't hesitate to yell if I need to stop. Okay. We are now going to simplify algebraic expressions. Okay? We are simplifying algebraic expressions. So, we are going to have to use the distributive property. Distributive. Did I spell that right? Property. I'm bad at denominator too. I always have to stop and think about it. Okay, we're going to use a distributive property. So if I have a 2 right here, and then I have an x plus 1, what do I do with that 2? What do I do with it?
You multiply by x.
It is 2x plus 2. Good. So I've got to multiply that 2 by everything inside that x plus 1. Okay? So I'm going to say 2 times x is 2x. 2 times 1 is 2. Okay? So we are going to do this twice. We're going to do this twice. So I have 4 times x is 4x. 4 times 2 is 8. Okay, now I'm going to do it again. 3 times x is 3x. 3 times 6 is 18. Now, we're going to talk about like terms. Now, before we define like terms, who wants to tell me what like terms I have in this example? Yes, ma'am.
4x and 3x and then 8 and 18.
Yes, I've got 2 sets of like terms. 4x and 3x are like terms. 8 and 18 are like terms. That means I can combine them. Now, we have been combining 8 and 18 for many years, probably since kindergarten. We've been combining numbers like 8 and 18. Those are constants. So don't forget that it's okay to combine constants because they don't have a variable with them. Sometimes we get so wrapped up in the algebra that we forget, oh, this is just basic math. I can add those two. So a like term is the same variable raised to the same exponent. Now, it's not going to be until chapter 3 that we really have to worry about that exponent thing, but I like to define it now. Same variable raised to same exponent. Okay? Same variable raised to the same exponent. And we do have 2 sets here. We have 4x and 3x. That gives me 7x. Then I have 8 and 18. What does that give me?
26.
Perfect. Okay? Can I combine 7x and 26? No, I can't. I can't combine. Okay? Now, this next one is tricky. Why is it tricky? What does it have that the others don't?
Negatives.
It's got negatives. Okay? So you got to be careful with those negatives. Students typically do okay with the first one. Okay? Negative 5 times y is negative 5y. Negative 5 times 3 is negative 15. Now, the place that students make mistakes is right here. Students typically distribute that 2 without any problem. But we're not distributing a 2. What are we distributing? Negative 2. Be careful. That is a mistake alert. If you make a mistake here, this is where you do it. You forget to distribute that negative. Okay? So we have negative 2y plus 16?
Yes.
Thank you. Okay? Negative 5y and negative 2y can be combined. Then I have negative 15, positive 16. Which has the greater absolute value? 16. So my answer is going to be plus 1. Oh, yes, you're right, plus 1. Good job. Sounds like I'm going to a wedding, plus 1. Just kidding. Okay, now I'm going to give you, can I move? Okay, this one is slightly more complex, but I have confidence you can do it. There's no negatives. I'm going to give you 60 seconds to do this. 60 seconds. Okay. I'm distributing the 3. The only thing that's different here is I have y values instead of a constant. Okay, we still had 2 sets of common terms or like terms, but now instead of having x and a constant, we have x and y. So 3 times 2x is 6x. 3 times 5y is 15y. Okay? 4 times 3x is 12x. 4 times 2y is 8y. 6x and 12x, 15y and 8y. So I should have 18x plus 23y. Okay? We did okay? No? Okay. Do you want to stay for help session? Yeah, okay. Okay, 18x plus 23y. Okay? Okay. Now we are going to do some substitution. We're going to do some substitution. Okay? 3x minus 4y. 3x minus 4y. Okay? So, what we are going to do here is we are going to substitute 2 for x. Then we are going to substitute negative 3 for y. So wherever there's an x, I'm going to put a 2. Wherever there's a y, I'm going to put a negative 3. Okay? So I have 3 times 2 minus 4 times negative 3. Okay? So I just plug those in. 3 times 2 is 6. Negative 4 times negative 3 is positive 12. And I get 18. Okay. Question? No, you're good? Okay. Okay. Now, this one is more complex because we have squares in it. This one is more complex because we have squares in it. Okay? Now, I'm still going to plug a negative 2 in for x and a negative 5 wherever there's a y. So I'm going to do that first. Now, I want you to look at how I'm writing it. I'm going to do negative 2 squared. Notice how I put that negative 2 in parentheses? That is a good habit to get into. Then I've got negative 2 because that is part of the original equation. That negative 2 right there is part of the original equation. Then I've got an x, and the x value is negative 2. Then I have a y value, and that y value is negative 5. Then I add that to my y value squared. Now, the number one mistake area with this is where students make mistakes. Okay? They write down the negative 2 like that. Okay? So what's the difference between this and that? Yes, sir.
The negative not included in the mistake. So when you multiply, you'll have like your answer and then make it negative instead of it being negative.
You are 100% correct. Absolutely correct. Here, what happens is you just square the 2. So you have 2 squared, you get 4, and then you still got this negative. That is a huge place that students make mistakes consistently. And it's something that will show up over and over and over again in this class. So you are much better off to put that number in parentheses, because here we are squaring the negative and we are squaring the 2. So the negative 2 times negative 2 gives me what? Positive 2. So when you square a negative number, you will always, always, always get what? Positive. Okay? When you square a negative number, you will always get a positive number. So negative 2 squared is 4. Okay, that's order of operations. I've got to do the exponents first. Now I'm just going to write down negative 2 times negative 2 times negative 5. Okay, and then what's negative 5 squared?
25.
Okay. Now, before I can do subtraction and addition, I need to deal with these numbers right here. Now, look at that minus. This is 4 minus 2 times negative 2 times negative 5. That minus sign belongs to that 2. Okay, it belongs to that 2. If you need to rewrite that, go ahead and rewrite it. Okay, rewrite it as plus a negative. Okay, now I'm just going to bring down my 4. Negative 2 times negative 2 is what? Negative 2 times negative 2. It's positive 4. Positive 4 times negative 5. Excellent. Negative 20. Okay? Plus 25. Now we are adding and subtracting. So what is my final answer there?
Negative 41.
It is not negative 41. Okay? So we've got some positives and we've got some negatives going on here. Okay? So what I would do if I were you, I would say 4 plus 25. Why might I do that? Because it's easy. And tell me why it's easier that way.
Because, yeah, like terms, you don't have to deal with like the negative versus just like terms. It's easier.
Okay. What were you going to say? Yeah. They're both positive. Okay? And I think that's what you were trying to get at. They're both positive. Okay? So I've got 25 and I've got 4. So if I add these two together, and it's completely fine to do that. We can change the order when we're adding. Okay? So then I have 29 minus 20. And we might look at that a little clearer because it's 29 minus 20. What's 29 minus 20? 9. Okay? That's the same as plus negative 20. It's the same. Now, if I had done 4 minus 20, I would have gotten negative 16. 4 minus 20 is negative 16 plus 25. So I still would have gotten 9 regardless of which way I had done it. Okay? Okay. Can I move off the screen? Okay. Now, do not make these harder than they are. Do not make these harder than they are. a word problem. You will not be solving word problems on a prep assessment. What you are doing is you are creating an algebraic phrase that aligns with this. We are not solving a word problem. We are creating an algebraic phrase that represents what's happening here. Okay? So, Sonia can keyboard. Keyboard is the same thing as typing, depending on how old you are. So, Sonia can keyboard 65 words per minute. How many words will she keyboard in M minutes? Okay? So, let's kind of think about this before we write down our answer. If Sonia was keyboarding for 2 minutes, what would I do? What operation would I do? 65 times 2. Okay? So if she was keyboarding 2 minutes, that would be 65 times 2. What if she was keyboarding 5 minutes? 65 times 5. 10 minutes? 65 times 10. Now, I'm asking, she is keyboarding M minutes. 65 times M. Good job. So my answer here is 65 times M.
Does it matter if you like wrote it as M parentheses 65? Or is this still the same thing?
M times 65 would be the same thing. It would absolutely be the same thing. I will say traditionally you're going to see it this way, but your way is not incorrect. The time that matters and the time that it gets you in trouble is when you're subtracting. Because if I have x minus 2, that is not the same thing as 2 minus x. Addition and multiplication is fine. Subtraction and division is not. That's a great question. Thank you. Okay. Russ. Russ has some nickels, and he also has some dimes. We are not trying to figure out how much money Russ has. Okay? We are writing an expression to illustrate it. That's all we're doing. Russ has N nickels and D dimes. Now, let's talk about his nickels. Let's talk about his nickels. Do we know how many nickels he has?
No.
We don't know. Do we know how much a nickel is worth? How much is a nickel worth? 5 cents. Okay? So could I write 5N to represent how many nickels he has? Yes, I don't know how many nickels he has, but I do know that every single one of his nickels is worth 5 cents. Okay? What about his D dimes? 10 cents. Okay? Now this is technically the correct answer right here because it says express this amount of money in cents. When do we ever do anything in cents? What do we use? Say it again. The decimal. We use dollars. Okay? So if I'm thinking dollars, what is a nickel represented in 1.00 dollars? 0.05. So if you happened to write this like this, and what would the dime be? Good. If you wrote it like that, I think you're 100% correct because my mind goes to the way on the right. Okay? Technically, this did say cents. So 5N plus 10D is the correct answer, but I 100% would accept the one on the right. Okay? Now, I'm going to give you another one, and I want you to draw a picture. Okay? When all else fails, draw a picture. Okay? The length of a rectangle is L centimeters, and the width is W centimeters. Express the perimeter of the rectangle. Draw the rectangle, and then go back to the length of a rectangle is L centimeters. And the width is W centimeters. You're not plugging in numbers, you're plugging in letters. So, here's my rectangle. The length of a rectangle is L centimeters. So if I write an L right here, have I represented that statement?
No.
Somebody said no.
I'm missing the width.
I am missing the width. Yes, I am just worried about the length right now, but you're correct. I am missing the width. What would the side opposite that L be? The same, okay? So here's L, and this up here is L, okay? Then what's the other side? W. And what's the side opposite W? Good. Perimeter means I add them up or I multiply? Add. It's the way around. And sometimes it's that definition that gets us in trouble. So don't hesitate to ask me to remind you of the definition, okay? So perimeter, we're adding them up. So is it correct if I say the perimeter is W plus L plus W plus L? Good. Do I have any like terms? Good. So I could have 2W, 2L. Okay? Question?
Didn't you also, am I wrong, didn't you also do 2 and then parentheses W plus L?
Yes, you absolutely did. Absolutely. Good. Good job. Okay. There are some problems on your homework that's got some fractions in them, so go ahead and you definitely want to mess with those fractions. It is to your benefit to get as much of the prep assignment homework done before Wednesday as you can. We will be practicing all these types of problems in class on Wednesday. If you do well in the class assignment on Wednesday, you'll do great on Friday. Okay? I will be in this room at 11 o'clock to help with any WebAssign issues. Bring your device. Bring whatever device you're doing WebAssign on. How are you? Did you have a good weekend?
Yes.
Good. Good, good, good.
Last week without a game.
You have a class right now? Okay, I got you. Yeah, feel free to come by at 1. Yeah. Okay, bye. Have a good afternoon. Were you able to access the stuff today?
I'm trying to get it, but I will try.
Let me know. Let me know if it's an issue. Hello. Have a good day.
I think I get it now.
Okay.
I don't have any more questions, I'll let you know.
Please do. Please do. You're good. Thank you. Alexis, is that right? I have had a lot of luck on my iPad. Is that an iPad? Doing WebAssign on the iPad. I'm taking a calculus class right now, and it does WebAssign, and I've had a lot of luck. Just so you know. How are you? Good. Have a good afternoon.
I'm going to stay for the health session.
Oh, you are? Oh, well, let's get you signed up. That's going to be the most important thing. How are you doing?
Good.
Good. You have a good afternoon.
I think I should go WebAssign.
Awesome. Then you are well on your way.
I thought it was due today.
Oh, I'm sorry. I'm sorry. Yep, it's due on Friday. So good job. You're ahead.
Since I won't be here Wednesday, is the assignment, is that on paper or is it going to be on?
I will. It is on paper, but I'll post it online. Now, will you be back on Friday, or you don't know really?
Should.
Good.
Thank you. I think I've made a strong case.
Good. Good job.
I appreciate it.
Okay, so will you do most of your stuff
No,
on
math, I like math. I just
your
like
iPad? Is that what you use a lot?